Welcome to the Mobile Workforce Podcast, where we sit down and have real conversations with business leaders that have been where you are. During these interviews, we'll dive into what it takes to improve systems and champion processes that maximize performance. Each week, our trailblazing guests share their experiences and understanding of the workforce to help inspire change, challenge our thinking, and share what it takes to successfully travel the road to profitability. Now here's our host, co-founder and chief evangelist of About Time and WorkMax, Mike Merrill.
Hello and welcome to the Mobile Workforce Podcast. I'm your host, Mike Merrill, and today we are sitting down with Marcello Scambaluri. Marcello is an expert on BIM and technology related to BIM, and he's actually been awarded the Best Speaker at Autodesk University's AU Awards for the last 8 years, so pretty cool. Obviously has a wealth of information and knowledge about BIM and how contractors should take advantage of the software that's available today and where the technology is heading tomorrow. So hello, Marcello, and welcome to the podcast.
Hello, Mike. How are you?
Doing great. Thank you. Appreciate you coming on today.
Thanks for having me.
You bet. We've had a few guests come on and talk about BIM. I don't know that we've gotten in the depths of the conversation capability or really some of the finer details on what BIM is today. But could you give us a little background on your opinion on how BIM was developed and maybe the history of that a little bit?
BIM stands for Building Information Modeling, and the idea is that you're not just building lines, arcs, circles, points, solids in a software to represent the building. You're actually building smart components that have rich data behind it. And when you do that, then you're able to use that information in a lot of different ways. So BIM's been around actually quite a while now. I started working with it technically 23 years ago is when I actually technically started working with it. But I think the term started to float into the AEC industry probably around the early 2000s, particularly when Revit started becoming more popular among AEC design firms, and so that's kind of been the buzzword. But quite honestly, this technology continues to grow and adopt. And so we are now, even though BIM tends to be the backbone of the technology branch of AEC, there are plenty of other new technologies that complement it. And I suppose we can get into that a little bit later, because we're going to get into like different terms that are around and things like that. And I'm here to try to clarify that.
Yeah, I think that'd be awesome. I guess one of the questions that I had, how is BIM treated overseas versus the United States? Is there a difference?
There is a difference. The thing with the way BIM is managed in the United States, and when you mean overseas, quote unquote, I suppose you technically mean probably in Europe and other places outside of North and South America. Probably is what you technically mean there.
Sure.
Well, just in general, BIM in the United States doesn't have a overarching regulatory body or standardization that is required. Let's put it that way. There are quote unquote BIM standards, but each project in the United States is not required to follow it. So in that way, BIM doesn't tend to be standardized from project to project. Now, in other places like Europe or even parts of Canada, they do have requirements, and so there tends to be more standardization in terms of the process for BIM from project to project. So that's kind of how it varies. But the technology in and of itself is still really the same. It's more of how it's organized and used.
Okay.
Yeah.
So the term like computational design, what
What is
What would
that?
that?
Let's wrap our head around that. Well, it's
Sure.
early in the podcast to start talking about that, but I guess we better do it now to get it out of the way.
Sure. Okay.
Okay, so this is what's been happening in the industry over the last 10 years. So by 2010, I'm sure most architectural engineering construction firms have heard of the term BIM. So what's been happening for the last, say, 10, 12 years is that as BIM started to take hold in a company's culture, and what I mean by that is that, let's talk about culture in a company because that's important, and technology that wraps, and the technology that's integrated within the culture of a company. And when I mean company, I'm just talking about every single company that would be involved in the AEC industry. Yeah, so it would be construction, architecture, engineering, facilities management. Okay, uh, so you could have technology in a company, and it depends on who you ask. Like, for example, virtual reality. You could ask someone in a firm, and I mean, I'm going to use the word firm loosely from now on. In eight means AEC. Do you use virtual reality? You ask someone, they're going to say yes, quote unquote. But what does that really mean? Does that mean you've got a headset off in the corner that virtual reality could be used at any time and only a few select individuals know how to use it? Or does it mean that it's fully integrated with the culture of your company? And what I mean by that is that is everyone on board with it, from marketing to management to sales to, are they fully aware? Could they at any point in time give someone a talk about exactly what it is? Could a report be written on it? Could it be part of your statement of qualifications and your marketing material? Like, it's culturally integrated. So that's what I mean by culturally integrated. So if what I've noticed over from 2010 on is that I'm going to put a lot in quotes, a lot of firms have integrated BIM culturally in their offices. So when you do that, you start to use BIM to its fullest potential, meaning you're now producing drawings, whether they're shop drawings or whether they're construction documents for design, and the backbone of them is done off of BIM and the BIM technology, meaning you've modeled it in 3D, you've had smart elements, you're coordinating with other team members on the project, you're producing drawings from it, and then also your marketing groups, your principals, your president, like everyone is involved with this process.
Okay. So are you seeing a lot of companies that have that integrated into their culture to that
Um,
degree?
yeah, I'm going to say larger ones for sure. Larger ones for sure. Smaller companies, and I can't quite define quote unquote small, but smaller companies tend to not have it as integrated in their culture. So now let's talk about the integrated with the culture. Now, the larger firms that have this integrated with the culture are using it to its fullest potential. At that point, companies are starting to look, okay, now what? What else can we do? So what's been happening over time is that now that it's fully integrated, is companies want to customize BIM. They want to change it and tweak it to their workflow. I mean, we can go in a bunch of examples, like out of the box, BIM maybe does one thing, but they want to tweak it to do more for their company, right? So this quote unquote tweaking tends to happen with customization. And customization, since we're in the 3D digital environment, comes along with programming. And so what we've seen over the last 10 to 12 years is that individuals and companies have become their own software developers, and they've started to customize BIM and make changes to it. It was a little more cumbersome early on. I'm going to say early on, 2010 or so, because you had to to customize, you had to do a lot of text coding. But what's happened since 2014 and on is visual programming has become a big part of our industry. So Dynamo, Grasshopper, those are two big buzzwords. That means that you can now take text coding and make it visual. And when it's visual, then it's a lot easier to learn and implement. So what's happened is, as visual programming tools came on board, more more and more AEC professionals have become programmers, and they've been able to make their own programs at an exponential rate compared to what has been done like early on 2010. So now with this integration of many individuals becoming programmers in a company, uh, with these easy visualization programming tools like Dynamo and Grasshopper, what's happened is that um, is that uh, is that BIM becomes expanded and becomes more, I guess, enlightened. And so you can customize, you can do all these things. And then the next level from that, which is not just customizing BIM, is using something called computational design. And what that really is basically a way to to automate, is a way to customize, is a way to do quick calculations um, on your basically on your BIM system through programming. And so computational design is just kind of the next evolution of BIM. And it's actually the reason it is now a big buzzword is because you have so many individuals programming, you have so many people using visual programming, it becomes a lot easier to do. We couldn't have the computational design, quote unquote, has been around a while. It was always possible from the early 2000s. It's just that it just didn't become mainstream buzzword until these easy programming tools came online.
Makes sense. So how does that vary from generative design?
Okay, generative design is just a byproduct of computational design. So generative design, so basically you've got computational design, and under computational design is generative design. Generative design is just a way of creating quick iterations of designs to generate designs using programming, basically is what it is. So it tends to give you you can plug in different options, and then through programming, through this computational design, we're calling it. Basically, I think of computational design as design using computation. It's what it is.
Okay. Self-descriptive. Yeah.
It is.
Sounds
It really is, because they're like, what's computational design? Basically, you need programming to make computational design possible. Just like you needed smart elements to make BIM possible. So it's a similar thing. So it's design using computation. So if it's design using computation, generative design is just one of the aspects of it. So generative design basically says, well, I have all these parameters. Maybe I want to make a building a certain volume, and it needs to fit on this space. And then so generative design can go through and give you all hundreds, thousands, tens of thousands of different options of the way the shape of the building could be, based on parameters you put in it. And then it helps. What it does is it speeds up the manual process, because normally what you would do is you would say, well, it needs to be this volume or this area, so I'm going to change this length and change that length, and then I'm going to run it through my design, and I'm going to see the result. Okay, now I want to change this length and that length, but you can do that through programming and computational design. And then that's kind of generative design in a nutshell. It's a lot more than that, but that's in summary what it is. I know I'm going to get in a lot of trouble for simplifying it. I get in a lot of trouble, Mike, for simplifying things. People tell me all the time I'm oversimplifying things, but in reality, I think things are sometimes a little too overcomplicated. So I try to break it down and make it simple. So so that's kind of my simple explanation on what it is. Now the question is, should you be doing generative design? I don't think it's for everybody, but what I think is happening in our industry is, if you're not getting into BIM, then you're going to need to get into BIM, and then eventually you're going to need to get into computational design, because you're going to find when you're in BIM, you're going to need to modify, you're going to need to change, you're going to need to, your workflow is going to need to be a little different, and then at that point you need to customize, and when you customize, then you're going to need to uh, basically use programming to do that, and then that basically in a nutshell is computational design.
So where does visual programming play into those two other aspects?
Yeah. So if you want to change, so if you're using BIM, for example, let's just use some concrete examples now and less hand waving. Let's say, for example, you're using Tekla to to model all of your structural framing, and then you're ultimately creating shop drawings out of it, right? Well, let's say you need to get the top of steel of all the roof beams and report it to whoever, maybe the structural designer so they could verify it or whatever, right? So you are using BIM at that point. Tekla definitely is BIM. It does have smart information. It's 3D modeling. It does have the ability to coordinate, so it does kind of meet those general BIM requirements. So I would argue that yes, you're using BIM if you're using Tekla. Okay, now you have two options. One, you could manually go through every top of steel and start writing down manually every top of steel, and then put it in a spreadsheet and email it to whoever needs it. Right? You could try to generate it through some report through Tekla, and I'm sure there's some savvy ways of doing that. Or you could say, you know what? I'm going to, instead of doing that, I'm going to customize this. And I'm really specifically looking at this particular parameter or property or something. So I'm going to actually program something to automate that, right? So now you have a chance to program. Okay, do you know text programming? Do you know C# coding? Do you know Visual? Do you know Visual Basic, or do you know .NET programming? Well, if the answer is no, then you can be like, okay, well then I have an option to use visual programming, maybe Dynamo or Grasshopper, or basically, and I get in trouble for saying this, but it's basically a boxes and wires. Can I place down boxes and wires in a certain organization to extract that information for me? And chances are you're going to be much more successful if you have no programming experience to put down boxes and wires to be able to get those tops of steel out, be able to write it to an Excel file, and be able to distribute it as you want. So that's just kind of a specific example of how you do that. And that's just one of tens of thousands of things you could do to just make your life easier. And, maybe you just saved 1 hour a week, but maybe that's 1 hour a week for one individual over a whole year. It can really add up.
Yeah, I actually appreciate the simplification of you breaking these things down, because I think the general public, even construction professionals, they hear the word BIM, they might know what the acronym means, like you explained at the beginning. They have a sense of what it is, but I don't think that a lot of companies necessarily dig much deeper than that
I
surface.
think, Mike, the reality is, I think a lot of construction firms in this day and age probably use BIM, but they don't know it
They don't know it.
because it's
Yeah.
almost, well, I mean, and that's a good thing, right? It's almost like it's just integrated in the culture. Do you use Revit? Yeah, we model grid lines in Revit. Yeah, we lay out our structural framing in Revit. Okay, well then you're using BIM. You are a BIM user. Get it on your statement of qualifications. You are a BIM user. Are we use Tekla? You know, yeah, well, we sort of use it. We use it to extract 2D plans, and then we lay everything out in AutoCAD. Okay, but are you using Tekla in some way, quote unquote? Yeah. Okay, so now you're using BIM, right? So I don't think it has to be something extremely complicated to get quote unquote into BIM. And then a lot of times what happens is, if you're like, well, we're already using Tekla or we're already using Revit to do little things, well then maybe you take it a little step further. Maybe and then, because what the advantage of BIM is that it allows you, since here's what BIM is really. That's the acronym, Building Information Modeling. But what the paradigm shift was back 20 years ago was going what let's back up even further. From the Renaissance, I suppose we can go that far. Hundreds of years ago, in order to express your ideas on paper, is things were simplified. Uh, Designs were simplified to be represented like diagrammatically on drawings, plans, and elevations, basically, for hundreds of years. Then maybe you could argue early 80s, mid 80s, the ability to replicate that digitally through AutoCAD or other CAD means, which stand for computer aided design, which really meant you're basically taking what you did on drawings and just replicating it digitally. Now that was important because you can make changes quick, you could use an undo button, you could snap to centers and endpoints and stuff like that. So it made the drawing easier, and you could do some repetitive task copying lines and things like that. What BIM did is it flipped all of those concepts on their head and said, instead of trying to represent things with lines, let's actually model in 3 dimensions the actual element. So it has the true length, the true size, the true property, maybe even the right material property. It has the right connectivity. And then through doing that, it writes it to a global database that's kind of hidden in the background. So whenever you see a view of it, of that particular, let's say it's a girder, right? A beam connected to 2 columns. Let's say you want to look at that girder in a 3D view. Well, all it's doing is referencing that database and displaying it in 3D. Well, if I want to see it in 2D on plan, it's not a different beam like it would have been with AutoCAD. It's the same beam referencing that global database. So what BIM has done is it has allowed the industry to not have to worry too much about doing things twice. So if you model it in 3D, well, now you have a plan. Now you have an elevation. You don't have to do it twice, right? But not only that, but since it's represented in 3D, now you can do coordination. You can overlay that with the structural model. Is there coordination issues? And so that's really the beautiful benefit of BIM. And I think, like we said earlier, I think a lot of companies are using it and they just don't know it.
Right. Yeah. So a simpler term would be digital clay.
I suppose.
They're basically, I mean, that's what it is, right?
Yeah. I suppose it's digital clay. Although I think some architects would argue that's not.
They don't like clay.
But I think that's fair.
So you mentioned earlier VR. So where does VR play into everything that we've talked about so far, and how is that utilized to?
Well, VR or virtual reality is just a fancy way of viewing and sometimes interacting with your 3D digital models. So it comes in really handy in certain situations, like if you want to. What's nice about virtual reality is that you no longer have to just visualize your, let's call them projects, on the flat screen on the computer. You actually have the ability to visualize it as if you were physically in that
Walk
space.
through it, right? Yeah.
Yeah, and quite honestly, there's a lot of really nice things that happens with that. First of all, it's a lot of fun to use. In fact, I've got a VR system here. That's one of my VR sensors there. Those are lightsabers, if the viewers are wondering, by the way. So
yeah, right.
A bit nerdy to have those together, but hey, that's okay.
I thought they were ninja swords or katana swords.
Well, I suppose you could argue. that they are
digital katana swords.
I suppose. So what virtual reality does is allows you to physically step into space, and it's a lot of fun. And a lot of times it's easier to visualize and realize a space when your brain thinks you're actually standing there. So like a lot of times what we'll do at my structural firm is when we're done modeling large portions of the structural portions of a project, is we'll go into virtual reality and do just one more quality control sweep. And it's like a lot of times it's just even just for quality control. Like we'll look if you're looking on a flat screen at a bunch of elements and you're not physically in the space, sometimes things don't look off. But when you're physically standing there with the virtual headset and you're standing on a roof and you're looking at all the beams, and then you see this little shadow being cast and you're like, what's that? And you walk over and you realize that the beam is up just a bit because it's casting a shadow a little differently. So your brain thinks you're there, and then you find these little things that kind of pop. And I like to equate it to like, if you saw a circle and it had a little notch taken out of it, you'd be like, that's not right. That's not a circle, right? I mean, but we know circles are supposed to be completely round and continuous, right? But when your brain is in a project and you think you're there, then you see things that just you normally wouldn't see in the flats. At least I don't. So it's fun to be there, and so virtual reality allows you to do that. It uses game engine technology, which then also allows you not to just look, but in certain situations you could touch. So if you need to, you can collaborate with others. You could see someone else in that environment, and you could talk, or you could paint over things. And then, even in extreme cases, which I've seen, some elaborate, let's say, programs allow you to physically move things. So if you don't like that particular furniture there, pick it up and move it in virtual reality. And so, like, you have the ability to not just look but touch, which is really cool.
Well, and I think I'm gathering as you're discussing this, and as you're talking about the technical side of companies and programmers and people embracing this more, it's becoming more mainstream to where maybe one day in the not too distant future, you can go to the furniture store and have a similar experience and envision, this couch in your space or this bed, headboard, whatever.
Yeah, sure. And it's already happening. I mean, if you buy something on Amazon, there are some products there that'll say, view this at home, or I can't remember the option. And you can click it, and then you can show, and then it'll actually show the object in. That's augmented reality, but it uses the same concept. Virtual reality. If you want to know virtual, well, there's, what, and quite honestly, I am not the, I guess, the digital reality expert, but you may hear these terms: virtual reality or VR, augmented reality or AR. The only difference is that augmented reality means that it's digital overlaid with the real environment. So if you just want to have one object, but you're overlaying it with the real world, then that's augmented reality. They also have a term called mixed reality, which is kind of in between. And I think there's others which I don't quite understand. But anyway, there's as long as you hear the word reality on it, it's usually meaning that there's some kind of digital thing involved with kind of tricking the brain to think that it's actually there.
So what is a digital twin, and where does it play into this conversation we've been having?
Digital twin. Okay. It's still early in the podcast to ask that question, but okay. Digital twin. I need we need to ramp up for that one. But let me just finish my virtual reality soapbox rant if I want to. A lot of times with virtual reality, if companies are looking to get into it, it can be a hard sell because the equipment's expensive. But really, you just got to let people try it, and then when they try it, they tend to be kind of hooked because it's cool and fun. And if you're using virtual reality and you're not having fun, you're probably doing it wrong. So we're just going to have to kind of leave it at that. Also, it's not an unknown concept to us as humans. Virtual reality. Virtual reality just means that we're tricking the eyes to trick the brain to think that something is there that's not there. But we've been doing that with all our other senses for tens of thousands of years, right? I mean, when you hear bird sounds at a museum and it's playing through a loudspeaker, I mean, that's virtual reality just through your senses, through your hearing. But somehow we accept that as just being part of normal life. So the fact that we're tricking our eyes now to trick our brain to think something's there is only just another sense that we're using. I mean, you could even argue drawings, and I mean, it's all some kind of augmented reality of some type to trick our senses to think something's there. So this is just kind of the newest wave of that. I think in 20 years we're going to laugh at all these big headsets that we were wearing to trick our eyes when in fact
Yeah,
we'll come up with better systems for that.
the contact lens.
Yeah, I don't know, whatever it may be. But yeah, so I think it's here to stay. I don't think everyone would have a virtual reality headset on at all times 100% of the time. I don't think that's important. I think just at this point in time it's good to kind of get in there and see your designs and realize them in a different way. Okay, enough on that. Digital twin. Digital twin concept has been around a while. Now, what does digital twin mean if you just look at the definition? Does it just mean that it's a twin? It's a digital twin of the actual building? In the definition itself, yes. So if you had a project that was existing, say, or you designed a project in BIM, you modeled it in 3 dimensions, and if you were to look at the project that got finished and constructed, and you were to look at the constructed project, and you were to look at the 3D model that was built, and if they look identical or they look like twins, is that a digital twin? By the definition of the word, the answer is yes. But you would say, well, haven't we been doing that with BIM all along? Isn't BIM a digital twin, right? Like, what is the difference? Okay, there's a big difference. And the big difference is the process. So I like to think of it this way. Digital twin is not a thing. It's a process. So if you're like, do you have digital twin on the project? Then you go, yeah, we've got BIM, we've got we've got the project, we've got a digital twin. No, it doesn't work like that. So I think that's the misconception. But digital twin is the process on how you use it. Now you could say, well, we've been using BIM. We use a 3D BIM to organize and coordinate and extract information from. So are we using the digital twin in the right way? What the term digital twin is supposed to mean, and I'm not the digital twin expert, this is kind of what I gather from the industry and what I've done personally, is digital twin really is the way you use the 3-dimensional model after the project has been built. So you build a 3D digital model for your design, your coordination, and maybe even to help the construction. That's not really part of the digital twin process. The building is now built. Okay, the building's built, right? So you're like, how many sensors do we have in that building? We need to change them out. And when do we need to change them? Okay, go in there and count all 5,000 of them. Or could you go to a digital 3D model, which would be the digital twin, and go in there and count up all the sensors, put in data in there on when it needs to be replaced. And then so now as the project is moving along, and it gets older and older, you don't go physically into the building all the time. You go to that digital twin and you use the digital twin to support what you're doing to the facilities management of the building. Now, the digital twin experts and academics are probably going to say there's a lot more to it than that. And there is, but I'm just trying to simplify it in kind of a simple way. So if what we're saying is if a project requires you to do digital twin and you were just using BIM in the traditional sense, then you're not going to be able to satisfy that requirement. So what I think I'd recommend to the listeners, if they're hearing this, is if you have a digital twin requirement, then you need to ask exactly what that means. What do you really mean by that? You ask the owner if they're requiring it. Okay, it means that when the project is built, we have an exact replica as the as-built, and it is functional in such a way and in a format in such a way that the building facilities management, maybe us as the owner in the future, we can all access that project. We have the ability to do it. We have the skills to do it. We know exactly what to look for it. Maybe even you put in extra things in there so that it even reads real sensor data. Like sometimes buildings have sensor data. That digital twin is actually monitoring that sensor data. Maybe it's earthquake. Maybe it's a movement in an earthquake. Maybe it's maybe it's the electricity that's running through it. Maybe it's the age of the sensors, or there could be so much stuff. But it's basically using it as the twin of the actual building.
Well, great explanation. I love your descriptions and how you're bringing this back down to earth, right? Where just the regular Joe contractor can get a sense of what some of these specific terms are. So how does somebody that really isn't leveraging these things fully start to utilize BIM and digital twin technology and these other things in their business?
Computational design.
Yeah.
I think the first thing to do is to assess where you're at, because I think, I've been in the industry for 23 years now. And one thing I realize is that our industry is full of extremely intelligent AEC professionals, and a lot of them sell themselves short. So I think when they hear the term digital twin, computational design, BIM, their immediate reaction is, well, I'm not using that. But are you? And we talked about this earlier, right? So what I would recommend to everyone who wants to get into it, quote unquote, whatever that new technology is, do an evaluation first of where you are, a real evaluation. Like, are you really using BIM? You probably are. Are you using computational design in some way? You might be, but you don't know it. Like, as an example, you may be getting Revit models from an architect. The architect laid out all the grids, everything out using computational design, maybe a Dynamo script. Well, maybe you find that out. Okay, well, then what you do is you say, hey, could you share those scripts? Could you share the computation that went into creating this quote unquote digital thing? Let's call it a digital thing, right? Maybe you have subcontractors who wrote little list routines or scripts or something to help do it, right? Maybe you want that as supporting it. So that way, when you do a full evaluation of where you are, you need to realize what you've already done and what you're involved with. And that'll give you a good idea of where you need to go, because you don't want to have to relearn things that you already know that you don't know. If that makes sense. So then do a full evaluation, I would say. And then if you realize that you were doing something that you didn't know you were doing, meaning through these terms, then you probably should be updating your website, your statement of qualifications. You should be bragging, quite honestly, about what you're doing. Because what I find is that in this day and age, technology just wraps everything in our industry. Even if you're out there tying rebar, right? You are involved in a digital project, a process that got you to that point of where you need to place that rebar, et cetera, right? So technology is a huge part of our industry. It just is. And with that, you need to be a technology evangelist. So you need to be telling everyone in the project what you're doing from a technology standpoint. Maybe you wrote a little script to extract, like I said, all those tops of steels. Maybe you think no one cares. Probably people will, right? You need to be telling the owner, you need to be telling the architect, and you need to be telling the subcontractors all the technology that you know and what you're doing. So you need to do a self-evaluation. You need to do a realistic evaluation. You need to then be the evangelist for what you're doing. And then at that point, you could then branch out and say, okay, this is really what we need to learn. We really need to get into visual programming around Grasshopper, because for example, every time we start a new project, we always get a rhinoceros file, which is another 3D modeling program from the architect. And we don't have to remodel this all again. Okay, let's now decide to start to figure out how to utilize that technology to make ourselves a little better. And so I think self-evaluation and then doing baby steps into the technology that you think will help either the project you're on or one you see in the future, then it becomes more real. You don't want to look too far out, like, well, in 20 years, let's do some fictitious esoteric project that may be in the clouds one day. No, I don't think that's going to help. And then you can dig your roots in, save some time, and then you branch out again. Okay. But I think it's when I say a self-evaluation, I mean self and project evaluation, because you may say, well, we only use this and that. So yeah, we're using Tekla, and yeah, we're using AutoCAD imports, but maybe you didn't realize that the designers, the structural engineer, the architect are actually using all these other technologies that you happen to not really know about, but you're physically touching because you're getting byproducts of that. Well, then you need to ask, right? And in our industry, we're not that good at that yet. We're not that good at project teams sharing everything they're doing, quote unquote. They're good at sharing what they're required to share, but they're not that great at sharing what they're doing. And I think we will eventually get there, but we're not there yet. So how do you know? You got to ask. And believe it or not, a lot of our industry is filled with like tech geeks. I mean, I'm one of them. So I know. So you could just spark up a conversation. Well, how did you lay out all those grids? Wow, you've got 500 of them and you gave them to me the next day. Oh, well, we used a script and oh, really? Well, would you share that with it? Oh, of course. And then through that, you start to realize what your project is doing, and then you can learn without even trying. You could learn what's going on in your project, you could adapt those technologies in. At least you can start to think about it. Oh, I saw how this would utilize, and then you could start to be the evangelist of that. Even though we weren't directly involved in it, this project utilized this technology and that one, and then I think that's the easiest way to start to absorb it because it's real. And then you may decide, you know what, we want to do that thing that the architect did, or we want to do that thing that our subcontractor did. Yeah, and then from that point, then you move on. So I'm going to call it self-evaluation, project evaluation, evangelist, and then reach out. I think that's probably a good place to start.
Oh, great answer, and a lot of great detail. I really love. I mean, I'll put a different term on it, but this is marketing. There's a marketing opportunity for businesses to not just brag about and share, but evangelize how these buildings are being put together, and whether they realize it or not, they are using BIM because they're being blessed by BIM, even if they're not the owner of the system. They're enjoying the benefits of the process.
Right, and you should quote unquote shout that from the rooftops because you were an integral part of that technology to make that project successful. Even if you, maybe as a contractor or subcontractor, were only laying out slab edges, right? But really, where did that come from? Where did it go? And then where's it going? Maybe it's going to be part of a digital twin. Maybe it's going to run sensors in the building that will last for 20, 30 years, right? So it's good to ask. You know what I'm thinking? You know how projects ask for as-builts, right? We could do a whole podcast on as-builts, right? There should be like as-builts, but part of the as-builts should also be like a summary of like as designed. Like, how was this as designed? Like, what processes went through this to get here? I think that would be a nice solid document too. I don't see anyone in our industry really doing that from a like a big picture view. I mean, I think I've seen that through BIM execution plans, but BIM execution plans are more of like, this is what we need to do. But a lot of people, believe it or not, even if they follow a BIM execution plan, if they follow it, first if they read it, then if they follow it, will do a lot of things other than that. And it's those things other than that that I think really should be known to everyone in the project. I guess that's what I'm kind of saying.
Yeah, I'm visualizing like a navigation route on GPS. I mean, you got the destination, you got where you are, but turn left here, turn right there, go around this corner, merge here. Basically, you're talking about the steps it took to get from point A to point B and documenting
Yeah,
that.
I suppose. Yeah. And, I did a talk at Irish University on a similar topic. It was basically not what I think is really good, and it's been really real good over the last 20 years is like I said, companies and firms that are in a project are really good at sharing what they need to share. And that usually is around digital models and drawings. But they don't think about sharing their intellect or their wits. But that's a huge part of a project, right? And so I had that discussion group, and what I'm trying to promote in the industry is to do more of this. Like maybe and it could help the design, or it could help it, the project down the future. So like, for example, the contractor says we need all the digital models from all the designers, so we could then start to create our shop drawings and do our construction. Okay, just let's say that's a requirement, right? Well, the designers are gonna hand over their models because they're required to, and sometimes even if they're not required to, they do it. But a lot of times they're not thinking, okay, you know what? Let's also share all the other stuff that we did that led up to the creation, right, of the model. And then even on the design side, like, I'd like to see more of that kind of exchange of wits. Like, a lot of times there's overlap, like structural engineers and architects. Like, the structural engineer may be designing all the exterior retaining walls, but the architect is modeling all the soil and the topography, right? And then like one's required to do one thing, one's required to do another. But a lot of times one firm will have a unique skill set that the other one could use. Like, for example, you may have someone in the structural office who knows how to model topography better than anyone else in the state. But the architect may not know that because they're not telling them that. But if they told them that, hey, we've got, you know, whatever, so and so over there knows how to do this. Would you like them to share that knowledge with you? So when it's your turn to model it, it's going to be easier, And I think this whole sharing of wits things could really benefit an entire project, anywhere on the level. So I think that's what we're kind of driving down into is being able to share that. And it's traditionally not what we do, because you're like, well, why? And then, like from the other side of it, it's like, well, why are we getting help when we're required to do it? Why are we asking another consultant to help us do that? It's like, that's our job. But a lot of times when it's your job, it doesn't mean that you can't ask for help, right? Or you can't give help or offer help. So I think that's kind of where we're going to. So maybe as you do a self-evaluation, you're looking into this technology and you start to branch out, also do a self-evaluation of what you think team members could benefit from what you know. Maybe you're the expert at documenting all the precast concrete panels, right? But it's not your job. But you could probably share that with someone else on a project outside your firm, and then they'd be able to be a little bit easier at it. Because what happens too a lot of times is when, what I like to think about it too. Sorry, we're kind of flying off topic here, Mike. But what this does is this sharing, this evaluation, this helping, this sharing of wits, is it creates this culture around your project and around your company, and hopefully around the industry, which is not this kind of finger pointing. Well, it's your fault when a problem goes wrong. It's your fault. Where did it, it's like, no, it's really all of our faults, but it shouldn't even be that, like, whose fault is it? You shouldn't be asking that question, and I think a lot of times when you bring things up, it's kind of like, well, why are you asking? Or like,
Yeah.
we don't need your help,
Yeah.
Yeah. And what I like to say is if that happens in a project, like, well, why are you asking me? And like, it's kind of this kind of defensive way of doing it, which tends to be more of a more of paranoia, like, well, the reason you're asking me is because you're trying to, there's something negative you're going to do, or right. But I like to flip it on its head, and I'd like to see more of the opposite of paranoia is pronoia, which is you have this delusion that everyone's trying to help you. And so that's what I like to see. And I've seen that in some projects. That's what I would like to see in every project. When someone says, hey, do you want to learn how to model topography? I know how, I can show you. Yeah, great. Or, not why are you asking me, but I know you're asking me because you want to help me. Yeah, come on, spend a day over here. I'll buy you lunch, and, or whatever. It's this whole pronoia type of attitude and culture that I'd like to see more and more. And I think we'll eventually get there, but I think it all starts with sharing your wits and your knowledge, and everyone, kind of working together in a project. And I have seen it here and there, but I've seen more and more. Okay, I'm done, Mike.
I love that. Well, so to wrap up, one last thing. So if I were to ask you, what's the main takeaway, like one short, succinct takeaway for the listeners, what would be the parting thought you would share with them from our conversation?
Oh, what do I want everyone to take away? I guess what we just talked about. Mike, wait, how about this? Mike, what are you taking away from what I'm saying? How's that sound? What are you taking away from it?
Well, what I'm hearing you say is that we are leveraging technologies that we may not be aware that we're leveraging, and we need to better understand what those things are, so that not only can we take more advantage of them, but that we can also share that message with others so that we can raise the bar for everybody.
Right. And these technologies will continue to grow. There'll be more and more terms. Maybe if you invite me in a year, I'll have more terms for you. Right. So I think that's it. I think don't sell yourself short. Right. You're probably doing a lot more than you think. You're probably doing a lot more intelligent work than you think. And share what you have, and, keep up the good work. I think that's what the message is here. because we're doing something right. I mean, projects are being built all the time, right? We're the biggest industry, one of the biggest industries on the planet. And maybe if you need help communicating, reach out to Mike with his WorkMax platform, and he can tell you how to do that.
Well, thank you, Marcelo, for joining us today. Really enjoyed the conversation and look forward to sharing this messaging and also this episode with our listeners.
Okay, thank you, Mike. It was really nice talking with you.
Thank you for joining us today on the Mobile Workforce Podcast, sponsored by About Time Technologies and WorkMax. If you liked the conversation we had today, or were able to learn anything new or helpful, please make sure to follow us on our WorkMax page on LinkedIn and on Instagram at WorkMax_. And subscribe to the show on iTunes or your preferred podcast platform so you will never miss another insightful episode. Also, if you enjoyed the podcast, please leave us a 5-star rating and review and share the show with your friends and colleagues. Your support means the world to us and will allow us to continue providing impactful information with others looking to improve their results in their business and, in turn, their life.